Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to describe what the inverse trigonometric functions are. So to start with, we're going to just focus on my favorite function here, y equals sine x. It's my favorite function because it has characteristics that remind me about myself. It's what's called an odd function. It has an opinion on everything in that it's defined everywhere. Again, that reminds me of myself. And it repeats itself over and over and over and over. So the sine function is my favorite function. Anybody watching this, if you're going to go into engineering or physics or any sort of hard science, you'll want to identify what your favorite function is before you move on. But anyway, so getting back to this is a picture of y equals sine x from minus pi over 2 to plus pi over 2. It's just a rough sketch. It's just real rough, doesn't need to be perfect for this discussion. Some important characteristics of the sine function: it goes through 0, 0. This would be the point pi 0. This is going to be an important point for us for this discussion right here. The sine function is a maximum at pi over 2. I wrote over here to the left something I'm going to use a little bit when we're graphing. Keep in mind that pi over 2 is approximately 1.5, pi being 3.14. So you could think of this point as approximately the point 1.51. This point, another important point for the discussion, minus pi over 2, 1. Now, in order for a function to have an inverse, it has to have a certain characteristic, and that characteristic is it needs to be 1 to 1. So if you're not familiar with that, please go back and review my video on inverse functions. The sine function as it sits here is not 1 to 1. It fails the horizontal line test miserably. If I draw a horizontal line right through here, it hits here twice, but keep in mind that the sine function keeps going forever. So this horizontal line actually crosses that function an infinite number of times. Now, in order for a function to have an inverse, it has to be 1 to 1. This one's not. But what we can do to make it 1 to 1 is we can put what I would call an artificial restriction on its domain. So we're only going to consider the region from minus pi over 2 to plus pi over 2. So if we do that, basically what that does is it eliminates all of this graph everywhere except for that little kind of S-looking piece. Right? Now, the sine function, if we graph its inverse, and remember that what an inverse does, if I have a function that takes A and maps it to B, then the inverse will take B and map it to A. That's basically what the inverse function does, is switch the x and y values. So I'm going to go ahead and do this in red. This point, pi over 2, 1, on the inverse function, that would be the point 1 pi over 2. Remember that pi over 2 is roughly 1.5, so 1 pi over 2 might be, I don't know, maybe about here. 0, 0 would again get mapped to 0, 0. And then minus pi over 2, 1. I'm sorry, that's minus 1. Right there, minus pi over 2 minus 1. That would get mapped to minus 1 minus pi over 2, or in other words, roughly minus 1 minus 1.5. So that would put that thing about, I don't know, maybe about here. Now, remember that inverses are reflections about the line y equals x. So basically, if we take this function and invert it, or I'm sorry, reflect it about y equals x, basically we would have kind of a concavity that looks something like this. Okay, so this is a super rough sketch here in red of the function y equals inverse sine of x. This minus 1 here reads inverse. That's not 1 over sine x. And what the inverse sine function is, this is the set of all y that satisfy the following criteria, that sine y equals x. So this is a sketch of the inverse function of x. I'm sorry, the inverse y equals inverse sine x in red. It is the function, it's the set of all y values that satisfy the following equation. Now, we should talk domain and ranges here. So y equals sine x, if we go back to the original here, in order for it to have an inverse, we restricted ourselves from minus pi over 2 to plus pi over 2. So over here, this is going to get up to plus pi over 2 down to minus pi over 2. And then to the right here, we're going to get as far as, whoops, I'm sorry. This is going to go to the right by an amount pi over 2, to the left by an amount pi over 2. So this function has a restriction on its domain here from minus pi over 2 to plus pi over 2. So the inverse sine function is only defined from these angles, minus pi over 2 to plus pi over 2. The inverse cosine function, very similar. It's the function that satisfies, it's the set of all y values here that satisfy the following. Cosine y equals x, and the inverse cosine function is only defined between 0 and pi. The inverse tangent function is the set of all values that satisfy tangent y equals x, and the inverse tangent function, similar to the inverse sine function, is defined between minus pi over 2 and plus pi over 2. Okay, so again, what is the inverse sine function? It's the set of all y values that satisfy this equation, sine y equals x. And it is only defined between minus pi over 2 and plus pi over 2. Or in other words, that's the domain of the inverse sine function. The inverse cosine function, y equals inverse cosine x, is the set of all y values that satisfies this equation, cosine y equals x. Its domain is 0 to pi. Inverse tangent function is the set of all y values that satisfy tangent y equals x. It's defined between minus pi over 2 and plus pi over 2. So that's what these functions are. There's also inverse cotangent, inverse secant, and inverse cosecant functions. I'm not going to talk about those in this video. The purpose of this video is just describe what these inverse trig functions are. Hopefully I've accomplished that. An important part about that is where they're defined. This is very important. The inverse sine function is only defined between minus pi over 2 and plus pi over 2. Inverse cosine between 0 and pi. Inverse tangent, similar to the inverse sine, between minus pi over 2 and plus pi over 2. So, hope this video helps describe what these functions are. Have a great day.